paper, Systems Theory, Science, War, and Construction, examines the confluence of systems theories and the production of architectural building systems in the United States. The two are related through the adaptation of pre-World War II techniques and knowledges that were transformed during the war and the immediate post-war period. After discussing the theoretical implications of systems theories, this paper will analyze the packaged house by Konrad Wachsmann and Walter Gropius, a building system that was developed during the war, which illustrates the unique manner in which systems theory would be explored in the field of architecture. Prefabricated, quickly deployable building systems were necessary during the war to house troops and strategic equipment. Prefabricated building systems were also needed to house large numbers of migrant workers adjacent to the factories producing aircraft, weapons, and munitions. Even during the war, there was the notion of 1940X, or the unknown but eventual end year of the war, in which the stepped-up wartime factory would be retooled to produce low-cost prefabricated housing for returning veterans and their families. So this paper proposes that there is a symbiotic relationship with the advancements made in technology and in industrial fabrication during the war, and a systems approach in architecture. Architectural building systems provide a concrete manifestation of the conceptual framework of systems theory. So systems theory was developed in tandem in both the biological and the physical sciences, challenging previously held definitions. According to the laws of thermodynamics, a physical experiment is a closed system in which a finite set of elements are in interaction and will tend towards a condition of entropy or loss of information as the system advances towards equilibrium. Argued through a systems approach, both organic and non-organic phenomenon are considered as open systems with interactions back to and from the environment. So it may be said that a system may be any kind of entity, physical or theoretical, that is composed of interrelated parts. There are common characteristics that systems share. There is a structure as to how the components are arranged, and a function or functions that each part performs within the larger environment of the system. Input is taken in from the environment and follows a process or set of procedures to produce an output. The output then acts to feed back information into the system from outside the system and acts to influence change within that system. The publication in 1948 of Norbert Wiener's Cybernetics, or Control and Communication, in The Animal and the Machine, following his 1943 paper, Behavior, Purpose, and Teleology, with Julian Bigelow and Arturo Rosenblatt, was grounded in his involvement in and exposure to the development of mechanical control systems, such as servo mechanisms, earlier in his career, and artillery targeting systems during World War II. A major challenge for the Allies was the incapacity for the anti-aircraft guns to make their target on Nazi aircraft during bombing raids. The aircraft had gained maneuverability and speed since World War I, and a new approach was desperately needed to predict how far ahead of the aircraft to aim the weapon. The weapons were fitted with gun detectors, a kind of analog computer that would calculate the plane's future position, and servo mechanisms that would control the guns based on the gun director's output signals. I have a diagram on the right. Trajectory tables were created which calculated the variables of the gun caliber, size of the shell, and type of fuse. These tables were calculated by hand by mathematicians who were known as computers. Wiener's wartime work in ballistics would lead him to develop the theory of cybernetics, and he would, by 1948, discuss its application in diverse fields, from the prediction of flight paths to computing machines, electrical networks, and neuromuscular behavior, among others. Whether mechanical or biological, the cybernetic system depends on feedback, which requires the communication of information within the system. The theme of self-organization and feedback mechanisms in the control of an organism or of a machine are clear similarities in cybernetics and system theory and are in striking contrast to the received notions of science up until that point. Concurrent to Wiener's work in cybernetics, biologist Ludwig von Bertalanffy was developing a group of thinkers around his notion of a general system theory. This theory sought to develop a unified series of science of principles that could be applied in analysis of any manner of an open, evolving system, whether natural, physical, or social. A key feature of Bertalanffy's theory was that it would be applicable, as Wiener had thought of cybernetics as well, to any kind of subject, exhibiting the qualities of isomorphism. Bertalanffy proposed a general systems theory of which cybernetics, according to Bertalanffy and not according to Wiener, should be one of the branches under the general principle. Bertalanffy's text, The Theory of Open Systems in Physics and Biology, was published in 1950, 2 years after Norbert Wiener's seminal work, and cites Wiener in his bibliography. In the following quote, he seeks to clarify the distinction between physical models and the organism. Quote, "The only goal of science appeared to be analytical, i.e., the splitting up of reality into ever smaller units and the isolation of individual causal trains. Thus, physical reality would be split up into mass points or atoms, the living organism into cells, behavior into reflexes, perception into punctual sensations, etc., etc." He continues, "We may state as a characteristic of modern science that this scheme of isolable units acting in one-way causality has proved to be insufficient. Hence, the appearance, in all fields of science, of notions like holisticness, of wholeness, holistic, organismic, just gestalt, etc., which all signify that, in the last resort, we must think in terms of systems of elements and mutual interaction." Bertalanffy's phrase, systems of elements and mutual interaction, is clearly demonstrated in the design of the packaged house. The system is a perfectly coordinated set of parts that can be brought together in myriad ways. The jointing system, keep it there for a sec. The jointing system was based on 2-, 3-, and 4-way connections between panels. I'm going to read the rest of this paragraph and then go through a series of slides to explain the project. The jointing system was based on 2-, 3-, and 4-way connections between the panels. All of the building surfaces were to be created from the same panel. So we'll see floors, exterior walls, partitions, and the roof. Using a modular bay of 3 foot by 4 inches, seemingly infinite configurations could be made of the system. An impressive aspect of this project lies in the abstract qualities of the house, in its uniformity and precision. The packaged house provided a new level of 3D sophistication to prefabricated building systems. And I'm going to take a moment, I think, to point. What this is discussing is the joining system here, the notion of the three-dimensional volume that at the single module, single module could be deployed in any of the different dimensions. And I'll go through, again, from new pencil points. This spread talks about saying, when we look at this, take this page and turn it upside down, and you'll see the same system as it would function in the ceiling and on the floor. And on the upper right, to take the page and turn it again, and we see that this universal joint is not only seeming to be the base plate of the system, but becomes the columnar system. And turn it again, and we see this deployed in all directions. And I think this layout is quite interesting for that. I will continue ad lib here. The system consists of the ingenious clip that would be set within each of the panels that would come together. The prefabricated system, this was the only aspect of the prefabricated house that was to earn a patent for the ingenuity of the shipping and having this clip come into space, come together. And we see here deployed as the panels slip together and get capped. And details that Waxman had produced in anticipation of the panel house. In prefabricated building systems, a closed system is one in which each of the parts are proprietary and designed for that system only. This is the case of the packaged house, where the very metrical units are not coordinated with building industry standards. An open system in prefabrication is one in which the very metrical dimensions would be coordinated with a vaster array of industrially produced materials and equipment. The packaged house is, in this light, a closed system and one that is utterly constrained to the use of the component parts. Yet, it is also simultaneously an exemplary open system. To follow Wiener's notion of a closed system, one would have to have the end goal in sight. That is, as a physical model of a system, the goal would be determined by the performance of the system. The missile would make its mark. The house would be determined at the outset by the system of its parts. This is not the case. The system of parts exhibit pure potentiality. In and of themselves, they do not predict the organism, that is the building. Rather, the goal or the teleological drive is in fact introduced case by case in its design, with each architect who would work with the parts. It could be argued that the goal of the system is to create enclosure, and that is certainly a concern that is addressed in the system. But unlike other prefabricated housing systems of the time, in which the unit was conceived at the room scale, the packaged house provides an almost unlimited variety of ways to enclose space without the preconceived design of the room. And here we see a page from Laszlo Moholy-Nagy, Art and Vision, in which he's commenting about the potentiality of this system to move on the truck and then to be deployed in various different ways. Another wartime emigre to the US, Bruno Zevi, in his Verso un'architettura organica of 1945, would unite this necessity for the post-war architect to address the critical housing shortage, merging a notion of the prefabricated house consisting of various manufactured elements and the potential for these elements to be brought together in various ways, emulating as such an organic approach, an open system through the ensemble of inflected parts. In the following paragraph, Zevi writes of his experience in the States, equating notions of industrialization and bringing this to represent the possibility of democracy to post-war industrially undeveloped Italy. The following is my translation, which is eliminated in the English translation of 1950. What is the most pressing question of the day in England or America? The prefabricated house, mass-produced in industrialized factories. And then he continues, in America, various designs of prefabricated houses have perhaps opened the way for new solution. One needs to prefabricate the base unit, baths, kitchens, plumbing, and heating systems, bedrooms, perhaps all of the spaces, but separately. These units then get assembled back together according to the needs of the various needs of the inhabitant who will live there. There needs to be the possibility to add or subtract units or spaces, to substitute larger rooms for when the inhabitant outgrows the smaller rooms, and vice versa, meaning that the principle of flexibility must be respected, and that of organic growth and reduction. And the system was then investigated through Neutra, giving the system to various architects to explore in a variety of ways. And Walter Gropius brought the panel system to Harvard University, where students were to design and find the flexibility within the system. Some pencil points. In February of 1942, the National Housing Agency allocated $153 million for the housing of displaced workers, defense workers. There was a production target of 4,200 houses, and in the September of 1942, the General Panel Corporation was set up to begin the manufacture of the packaged house. The test house that Waxman and Gropius showed in Somerville, Massachusetts, followed the guidelines of the TDU-1 house. By May 1945, with the end of World War II, the house was still not in production, despite enthusiasm for the project. But the house could have a second chance in the enormous post-war demand for returning GIs and their families. The General Panel Corporation was formed to make the packaged house and raised funds to take over the former Lockheed aircraft factory in Burbank, California. Factories that made armaments could be retooled to make houses, and there were incentives of federal grants to be made available. Waxman took the leading role and set out to design the factory production line, which was ready by mid-1947, but the project erred in its timing again. By that time, the Veterans Emergency Housing Program was canceled and the government withdrew support. Waxman himself slowed down the process. With his ingenious four-way connector when his ingenious four-way connector was ready to go into production, he retracted the design, slowing down the process with fatal results. He had missed his timing, had missed his mark, and as his custom design panels were then too expensive to fabricate, they were replaced with standard joists and framing. This was too much for Waxman because it completely undermined the universality of this system, which was of utmost concern for him. As he relates in his biographical work, Timeline, quote, I had started the basic design for this housing system under obscure conditions in Europe, but also as a result of my experiences as Christoph and Unmak earlier in the 20s and 30s, always being convinced that this approach represented the only possible way to deal with modern housing. I had come to the United States and redesigned the whole system in Lincoln, Massachusetts with Walter Gropius. We had built several test houses and finally a gigantic factory. I had learned enough to understand that the principle in itself was wrong. And when I wanted to create the real product, it was too late. The title of the 1984 book by Gilbert Herbert, The Dream of the Factory-Made House, Conrad Waxman and Walter Gropius, is telling in that the packaged house remained a dream and that it never did go into production. So it's perhaps at this point when the system that Waxman had designed was so opened that it just had to blow apart. Thank you.